count these around the green section, 2, 4, 6, 8. This guy has his 8 valence. The other atom, if you count those X's and dots, there's 8. The spot between where the green and the blue overlap, that is the bonding point between the two atoms. And in there, you're going to see 4 electrons being shared, and it's even. If you can have a single, you can have a double, and if you can have a double, you probably know what's next. You can have a triple. Triple. Had to get a new pen. All right. Shares 6 electrons now. Yes, the sharing between the atoms is even, and let's just get busy and look at an example. Let's see, a good one would be nitrogen. Let's say we had 2 nitrogen atoms bond together. Again, your very first step is you better find nitrogen on the table. There he is. He's in this green spot, and just move up and find that Roman numeral, which is a 5. Makes it a heck of a lot easier. Okay, so I get 5 for him. I get 5 for him. Dude, you got to take his 5, you move them around, you shift them, but in the end, he better have an octet, he better have an octet, and there better be 6 shared electrons between the two. So good old nitrogen looks really weird, but he has the ability to pull this off. Oh, that's it right there. There's his 5. Now the other atom comes around with his 5 and places them in those positions, and then you got to count. This guy, now if you count in the end, there's 2, 4, 6, 8. He's got his valence of 8. The other nitrogen atom, if you count these, 1, 2, 3, 4, 5, 6, 7, 8, he's got his octet. In that space in the middle where the 2 circles overlap, which I'll put in red, is the bonding point, which contains 6 electrons, and in there, my friend, it is even. Triple, double, single. Now, there is a shortcut. Maybe I shouldn't show you that shortcut quite yet. I'm going to hold off on that shortcut just for a second or two. Okay, we got one more. Ooh, where am I going to put that? Is that going to fit over here? Ooh, that's going to be tight. I think I better move him down to the bottom. All right, let me put type 4 here. Type 4, very strange, and you can tell by the name something's different with this one. This one is called coordinate, covalent. And if you take the name apart, you can kind of get an idea of what's going on. Yes, it's covalent, so we're still sharing coordinates. If you were in math class and you heard that lovely math teacher say, hey, we're going to plot these coordinates. I know you guys don't like to do that. But what it means is there's a certain spot. So in number 4, there is a very special spot where some sharing is taking place. And it's a special type of sharing. So let's see. I want to keep it the same order. So shares, and it's still going to be 2 electrons. And here's where it changes. It is not even between the 2 atoms. It is uneven. Which again, it's not going to make much sense until I show you, which I'm going to show you right now. Let's just do this. Let's get this example. Now I'm getting near the bottom of my screen, so I'm going to do it over here to show you. Okay, so let's say that you had neon coming together with oxygen. Yeah, watch this little trick. So let's start with good old neon. Look where neon is on the table. Cha-ching! Whoa, now that's a special column. We learned about him in topic 5. Hey, all of these guys, if you go up and grab that Roman numeral, you'll see that Roman numeral is an 8. Yeah, well, he's a noble gas. He already has a stable octet. So neon, yeah, I'll place his 8 valence. That won't be too hard. Now comes good old oxygen. You look up oxygen on the table. Here he is. Go to that Roman numeral right there, which tells you 6 dots. I'll use X's so you can see them. Goal in the end is for each to have 8. Well, let's take a peek. Neon. If you look right here and you count those dots, it's kind of a no-brainer because he had 8 to begin with. He's a noble gas. Oh, but oxygen is a complete little leech. Look, if you take a look at his now, he came in with 6. Here's his 6. And what he'll do is he'll shove them all to the side of the sublevels and orbitals, and then boom, he adds these 2 to his 6, and now he does have his 8. And right in the middle, there it is. This right here is, yes, you're sharing 2 electrons, but it's not even at all. It's uneven. Because if you look inside, both of these electrons, valence, came from neon. Oxygen doesn't supply a single thing. So when oxygen spin pairs its electrons, it shoves them over all into 2 electrons per orbital, leaving a complete orbital open to leach onto neon and grab his 2. That is a strange one, but that is a coordinate covalent bond. All right, let's do a practice. A number of practice ones. Okay, so number 1. Okay, now you on your own. Let's put 2 sulfur atoms together. Okay, so here's what I want you to do. Look up sulfur on the table and get his number of valence. Obviously, in this case, it'll be the same for this atom. I would love for you to use like dots for this sulfur, X's for that sulfur. I want you to organize them and form some kind of bond here in the middle. A single, a double, a triple, or a coordinate to covalent. But in the end, he better have 8, and he better have 8. Okay, give it a shot and see what happens. Okay, so you looked up sulfur. Sulfur, good old sulfur, that sucker has 6 valence. So you would have 6 dots. Oh, you better have 6 dots for him. You could have 6 X's for that sulfur, placing those guys in their spots, hopefully. And then comes his 6. And in the end, this sulfur has his 8, 2, 4, 6, 8. This sulfur, 2, 4, 6, 8. And right in the middle is your double bond. Now, there is a shortcut. Here's the shortcut I was talking about earlier. The shortcut for writing this thing, which you're going to see a little bit later, the shortcut would look like this. What they'll do is they'll use this bar correlates with these two shared electrons, and this bar correlates to these two shared electrons. And so what they could do is they can write the structural formula of a molecule using just the bonded electrons using a dash line. And each dash line consists of 2 electrons. Okay, so if you see some dash lines, that's what they're doing. 2 dash lines, double bond. Okay. So you could say, hey man, that sucker was a double bond. Now, something that might help you visually, I don't know what helps you to learn the best, but I have seen students do this, and if we were in person, we would do it this way. This guy has 6 valence electrons, so I could use 6 red M&Ms. This guy, also 6, let's just say I grab 6 blue M&Ms for him. You can take these 6 and place them anywhere you want. You take these 6, place them anywhere you want around him. But in the end, we're looking for, obviously, an octet. And what I drew here is the same thing that you would see. Here comes his 2. Here comes his 2. And so you can see it visually as well, using like M&Ms. And there is that double bond. Okay, good. How about we take a look at this one? Try the second one. Let's try, how about you put together 2 iodines. Okay, iodine. Hey, there he is way down there. Scoot up. You get 7 for each. All right, well, let me grab 2, 4, 6. I'll grab 7 oranges for him. I'm going to grab 2, 4. There's his valence. Here's his valence. And organizing these. Now remember, outside of the bonding area, pretty simple, man. You have to go back to your 2 per area rule. So what you can't do is this. You can't put 3 there. You can't tuck in 3 valence. But between the 2 atoms, the bonding point is where the 2 per area kind of goes out the window. And boom. So you probably have, using dots and X's, you probably have that. And on your assessment that, when does that thing due? I don't know, who cares? But when you take the assessment, I'm asking you what kind of bond is in between. And so be prepared to identify it. Hey, it's a single bond. And that's it. 3. 3. Yes, we have to. Dude. Okay. Did I do this one already with you? What the heck. Give nitrogen a shot. No, forget this. Let's do arsenic. Okay, there. Try arsenic now and take that guy and get octets for each. All right, arsenic. Where is that guy at? There he is. Scoot up. Yes, he's got 5 valence. All right, I'm going to grab 5 green M&Ms. I'm going to grab, I need to use this color. These ugly brown ones. Okay, 5 and 5. Yeah, you're pretty short coming in, but in the end, you're just going to have an octet in the end, and you can kind of tell, maybe you can tell, you're going to have to pull off a pretty cool trick between these guys. And the other two, it doesn't matter where you place them. Just don't do this, because we try to pair these things up. Boom. So you probably have 2, and then put 3 in the middle. There's his 5, and then the other arsenic comes around and throws in his 5, and right there, that is your triple. And notice how it's even. All right, yes, those are somewhat easy because it's just diatomic. Di means 2, and you only have 2. Well, that's not the way all this works. So let's expand now. Let's get out of these little diatomic ones, and let's get into polyatomic ones. Poly simply means many. So let me clear the board, and let's start off. Nothing too hard. It's time for us to bring in good old hydrogen. That sucker's very common. Okay, so let's say if you have gas feeding into your house, like natural gas, or if we were in my chemistry room, we have those gas lines throughout the room. That gas that we use is methane gas. And methane gas is composed of 1 carbon surrounded by 4 hydrogens. And the key is all nonmetals, so we're going to share. Now, hydrogen is very small. He will never get an octet. This is an example of him behaving as helium, which is a duet. I think the best thing for you to do is just watch me do this one. Okay, so here's what I do first. I'm going to take a look at the middle guy, good old carbon. There he is. Here you go. Here's your first 4. If you move up, there's your Roman numeral. That's a 4. Hydrogen, yes, I know, way over here in the wrong spot, but the key for him, 1 valence. So he gets 1, he gets 1, he gets 1, and he gets 1. But here's the best thing about hydrogen. In the end, he wants to be like helium, which means only 2 valence electrons. So what I do with hydrogen is I always put out his 1 valence, and he's going to get 1 in return from the atom that he is bonding to. So I'm going to put his 1 valence here, and right away from carbon, I'll take 1 of his valence and put it over there. Now, why do I do that? Boom. Hydrogen has his 2 valence, which is a duet. And I would do the same thing with this hydrogen. I'll place his 1 valence, and right away he'll get 1 in return from the atom he is bonding to. This H does the same thing, and so I'll do that. And this H will throw out his 1 valence, and right away he gets 1 in return. And if you go around and look at all of the H's, each H has 2 valence. There's his 2. There's his 2. There's his 2. All 4 of those are stable. The carbon, okay, he's larger. He better have 8 in the end. And if you look at carbon and count them up, he has his 8. It's all these guys right here. 2, 4, 6, 8. Shortcut. to write that, the shortcut to write that would look like this. Where they'll use little dash lines that represent the point at which two electrons are shared. Now, even that is kind of a hassle to write. So you could even reduce it further. You could reduce it to this, which is what we're going to use the rest of the year. We're going to eventually simply use these, but this is the progression of this thing. Here's where all electrons are being shared. I can give it a shortcut by taking the dots out and using some lines, and then ultimately I can combine all of this together and write a shortcut. Okay. That's the deal with hydrogen. So whenever I throw a hydrogen at you later today, that's the idea behind him. Matter of fact, let me give you a hydrogen one. Let me reset the board. Let me get rid of these. Now I know I have an advantage of M&Ms. I can move them around. You with dots and X's and everything else, I know it's a little more challenging. And that's why I would not use a pen in this topic ever, because you will have to go back and erase. I can guarantee it. All right, so let me enlarge the molecule now. Let's continue with this hydrogen idea. Just good practice. So let's put a carbon here and here. Remember, you have to write it the way I write it, because this is the way this molecule is structured. I want an H over here. I want an H here, and an H here, and an H here, here, and here. Okay, let me do this. These are the spots where electrons are going to be shared. How many? That's what you've got to figure out. And the only reason why I do this is because sometimes students think that, oh, this H and this H are sharing electrons. No, you're not going to have an H share with an H. Okay, so with those spots that I put in red, use dots, X's. Your symbols are endless. You can use dots, you can use X's, you can use a box. You can use a box with a dot. You can use a circle. You can use a circle with a dot. I've seen students use stars. I've seen students use hearts. I've seen students use triangles. Now, I will save you a huge headache. And that huge headache is this. You can use the same symbol for all of the H's because they're never bonded together. Now, these two carbons, you need to use a different symbol. So you better change it up for these, because I have to grade you and see if you got the right setup. Okay? So use two different symbols for the C's and use the same symbol for the H. You should have 3 different symbols. All right, I'll give you some time. Go ahead and organize that one. Okay, so the first thing I do is I always do the H's. Let me get rid of these spots. And the reason why I do H's is because they're very simple. H's have one valence, so let me use yellow. So here's his one, his one, his one. Okay. Carbon, if you look that guy up, he's got that valence of 4. There's his 4. And here's this 4. Reason why I do H's first every single time is because he will put up his one valence and he gets one in return every single time. So he'll put up his one and he'll get one in return. And if you notice, as I go around, I have fewer options available to the carbons or the other atoms that it's bonded to, because I'm using up its valence. So he'll put his one up and he gets one in return. So at this point, this hydrogen has his duet. He has his duet. He has his duet. Dude, it's done. Those 3 are done. It cannot change. All right, I'll go over here to this side and I'll put up one and I'll get one in return. put up my 1, I'll get 1 in return. I'll put up my 1 and get my 1 in return. He has his duet. Done. Don't touch those. He has his duet. Done. Don't touch those. He has his duet. You're done. Don't touch those. And just look what's left. You only have 1 for this carbon and only 1 for this carbon, and it's screaming at you to put them together. Counting the carbons. Counting the carbon valence now. Now, this carbon right here, if I look, well, there's 2 of those, there's 2 of those, here comes these 2, here comes those 2, and boom, he now has his 8. If I go to the other carbon and I count, he's got those 2, 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 for a total of 8. There is the bond between these 2 carbon atoms, and that kind of bond is a single bond. But each has 8 in the end. Now that's a huge mess, and so that's why a shortcut would look like this. Because it's way too much to draw and write every single time. Well, I hate to tell you that, but that's a pain in the butt every single time. So you can reduce it even more, and you can do this. That is this carbon. Those H's, there's 3 of them, 1, 2, 3, so that part's done. This guy is this carbon, and around him I've got 3 H's. And so you can write it like that as well. Or, more advanced chemistry classes, boom, you can do that. Yeah, that's those lovely hydrogens. So that's what I do first. And then some students go, okay, well, don't do it with the M&Ms or Fruit Loops. Do it with dots and squares like we have to. It's like, okay, well, that's not hard. I do the same thing. If you watch this, let me get rid of the crap that's on the board. I can do the same thing with dots. I do the same order. Carbon, carbon, hydrogen. Okay, so I know that he gets 1. All H's get 1. So I'll use red for those. So I know that he's got 1. Well, he's going to put it next to the atom he's attached to. He has 1. I'll put it there. He has 1. I'll put it here. And I continue all the way around for the H's first. They're done. Now, if I was to grab like blue, okay, I know this carbon has 4 valence, but I also know that if H puts up 1, he gets 1 in return. So I'll use a dot. There's 1 of his valence. Here's 1 of his valence, and the other one has to go there. I got 1 dot left. The only place the dot can go, it has to go over here to bond with this carbon, so I'll put that dot here. This carbon, he's got to have 4. Well, I don't have a choice. One of them has to match the H over here, the other one has to match the H over here, and then I need an H over here. And I've got 1 green square left. Has to go here so that the bond between the 2 C's shows up. Each one has 8. Do the hydrogens first. See what's left. Distribute them, and hopefully they have 8 in the end, with a wide variety of symbols. All right, let's try another one. Let's try this one. Okay, and again, I'll help you with the bonding areas. So there's a sharing going on here, and here, and here, and that's it. Only 3 spots. Okay, give this one a shot. Okay, so I know he gets 1, he gets 1, he gets 4, and he gets 4. Okay, H is always first. He puts out his 1, gets 1 in return. That sucker is done. He'll put out his 1, he'll get 1 in return. That sucker's done. Don't touch those. Okay, now comes a, wait a minute, I have an extra, there, that doesn't work. Now I have extra electrons in place. I could put them down here, and I could try a single. If I try a single, look at the carbons now. This carbon, 2, 4, 6, he's short. If you start with singles and then work your way up to doubles and triples, you'll see there's a beautiful pattern. This sucker is short, which means the bond between his partner is not large enough. I need to increase the size of the bond. A single is not enough. So I'm going to try a double now. I'm going to try a double. And they'll just see where I'm at now with the double. Now this carbon, 1, 2, 3, 4, 5, 6, 7. He's still short. He needs to get 8. So I know, and this carbon's the same thing, 1, 2, 3, 4, 5, 6, 7. He is still short. That means that bond is not large enough, because I have to get to 8. Well, a bond larger than a double is only a triple, which means he slides in this one, but you better slide in this one along with it. Now if you count this carbon, 1, 2, 3, 4, 5, 6, 7, 8. He's got his 8, and this carbon the same thing. 1, 2, 3, 4, 5, 6, 7, 8. If I was to do it with dots, hearts, squares, circles, X's, I would just do the same thing. One at a time between the carbons. If it's short, I'll erase, increase the size of the bond. This is definitely a pencil topic. Don't use pen. Okay. Let's see. Where should you go next? Oh, yeah. Okay. This one. This one. Bonding locations. You got something going on here, 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 and here. All right, get carbon with a valence of 8. Get those hydrogens with a valence of 2. Okay, this time I will just use dots and X's like you are using. Yeah, this one's not too bad. Okay, well, I know hydrogen comes in with 1, so I'll just use an X for him. So here's his 1, here comes his 1, here comes his 1, and here comes his 1. Okay, I got 4 for the carbon. Well, don't have a choice. One of his 4 has to go here. The second one has to go here. There has to be something between the two. So I'll try put 1 there, and I'll put 1 off to the side. Then I go to this carbon. Okay, he's got 4, but you have to match the hydrogen, so 1's got to go there, 1's got to go there. I need something here, so I'll do this, and I'll put his 4th one here. And then just simply go back and count the carbons. This carbon, 1, 2, 3, 4, 5, 6, 7. He's short. This carbon, 2, 4, 5, 6, 7. He's also short. Dead giveaway. Get inside here with the bond, and you need to make it a larger bond. You can kind of tell, maybe some of you are really good at patterns, you can kind of tell what's going on, but if you count in your short, increase the size of the bond between the carbons, which means take that blue square and put it here, gone. Take that green dot and put it over here, and try a double bond between there. Now if you count, yes, 2, 4, 6, 8, he's got his 8. this carbon, 2, 4, 6, 8. Because you have to look all the way over here. There's his 8. And there is his 8. Nice. Okay, let's just shoot for one more. Okay, one more. This is quite the jump up, but I think you're ready. Okay, let's jump up. When you copy this, copy it carefully. Because if you copy them in the wrong spots, it's not going to work. All right. Yeah, I told you, these things can get large. And actually, this is a small one. Whoo! Okay, my cat is here. Great. All right, man. Take your time. Hey, I need different symbols. You got a bunch of different C's. Boy, you need a variety. All right, have fun. Okay, H is first, man. H is first. I'll use blue this time, and I'll use dots. So I'll put one there, there, there. There's the H's. Easy. Oh my God, we got so many carbons. Okay, so this carbon right here, I'll use X's. Well, of his 4, 2 have to go there. So you could do this. Now, I'll give you a huge hint. If you have a single electron all by itself, it's not going to work. If we're trying to get to 8, then you can't have a single if you think about it. So they have to be paired up. So when I start to the left, from where to the right, I realize there's no way. I need these things in pairs. So I'm going to move right now this X over here. Now I'll probably get to 8. All right, now here comes this carbon. Well, he has 4. There's 1. But you have to match up these two because it's a double bond. I've used 3 so far, which means only 1 can go there. It's one that's left. Now it's his turn. Okay, so what color do I need? I could use orange. Okay, so now I got this carbon. Well, one of his 4 has to go here. One of his 4 has to go here to match the carbon electron from that guy. Has to go here. I've got 2 left. I could put 1 here and then 1 here. This pen's not the best. But if I have a single electron, I will never get a total of 8. So not bad to put it there, but it's not going to work. I need these things in pairs. So I'll put it here. This carbon, shoot, what do I have left? Well, I'll use black, but I'll still use a different symbol. Let me use, I'll use a star. This carbon, well, he has to put one of his 4 here. He has to put one of his 4 here. He's got these 2 sitting here alone. Sorry, you need to pair those up to form a double bond. And bada boom, bada bing. He has his 8. Oh God, I hate to do this, but I am. Okay. There's his 8. There's his 8. Oh, my cat won't leave me alone. Here's his 8. What do I have left for colors? Okay, I'm gonna go to a light blue, and probably looks like the same as the other blue. There's his 8. Woohoo!